So Morgan, we've got a big blue bin full of sand here. What are we doing today?
Okay, so this is a simulated model of what Mount Scott looked like millions and millions and millions of years ago.
Okay.
Now, when you compare this to the Mount Scott we see today, it is very, very different. So we will be pouring water to do the process that is shown through millions and millions of years very quickly using sand and, well, water.
Okay, what's the name of that process?
Weathering and erosion.
Fantastic. So the rocks that we see today at Mount Scott, millions of years ago, were covered by other rocks. So that's how they formed deep underground, because they were deep underground. So today they're not deep underground, are they?
No, not very deep.
They're right at the surface. So how did that happen? Well, why don't we run the experiment and create our simulated model. And so if you'll pour on this side, I'll pour on this side, and we'll just see what happens, okay? Got it? All right, let's pour together. Yeah. Okay. Whoop, there. Okay, I got a canyon going. We're eroding, and all that water is moving all those grains of sand out. And it's carving down through the soft rock. Oh, and what do we see? What do we find there?
We found a rock.
Oh, we're seeing it come through.
Oh my, it's a
I'm
rock.
out of water. There you go.
I found another rock. What will we do next? Tune in later because we're too lazy.
So great. So what do we see? Stop right there. So at some point millions of years ago, after enough rain and wind and ice had torn apart the softer rocks that covered up this magma chamber, we started to see it appear at the Earth's surface, natural, as the Earth eroded away from on top of it. So here we can see a piece of granite, and this represents a piece of gabbro. And today, if we were driving up, all of this sand and all this soft rock is gone now. It's all been removed by erosion. And what we see left behind are these hard bits that represent that hard magma rock that's left behind. So this is cool. Put some over here so that well, there you go.
That's a cool rock right
There it is. Sweet. So stop right there. So if you were to drive out to Mount Scott in the Wichita Mountains today, you drive your little car around these big mountains that look like they're sitting out in the middle of nowhere, just like this rock is. Because that rock only formed in that one spot. And it took millions of years of erosion to expose it. So you and I can go hike there and have fun and learn something. Do you know what igneous rock is?
Yes.
What is it?
An igneous rock is a rock that's formed from molten lava that has cooled down over many years.
Wow, genius at work. That's correct. So molten magma, which is what we call lava that's underground, molten rock, cools very slowly and it forms large crystals. But have you ever wondered how we see these deep, large crystals, igneous rocks at the Earth's surface? If they cooled and formed deep underground, then shouldn't they still be deep underground?
Yeah.
That's strange. So the first thing that we're going to do, Morgan, is we're going to need to fill this pan up with sand. We've got to make some rock that we can then make our magma inject into, okay? So take a scoop and start to fill her up. I'm just going to set this right here and let you scoop away. Oh, that's great. We're going to keep doing this until this is full. So now we've filled up our 3-inch tall baking tin with sand and essentially compacted it to make a crude sedimentary rock. But we want to inject that magma into that sedimentary rock the same way that magma is forced up through pressure from deep within the earth into the overlying rock. In order to do that, we need to add some pressure, and we're going to use this foam to do it. Okay, let's put our glasses on, make sure that we aren't injured in the process of creating this intrusive body. And what we're going to do is we're going to put the nozzle up into the bottom of the pan, through the pan in the hole we've made, and very gently start to pump foam into it. I'm going to go in here, and we have our hole, and I'm inserting the tube, and now I'm going to very slowly start to add foam. Okay, I can feel it going in to the bottom. And it's going to slowly build up. Now we may see the top start to tilt a bit and crack as the pressure, oh, there it is. You can kind of see that? You see what's happening? What's happening once you describe it?
It seems to be splitting in half because the pressure is so large.
Sure is. So what do you think happens when big cracks form as magma is forcing its way underneath?
I don't know.
Well, water can get down in there, right?
Yeah.
Well, what does water do to rock? Do you have any idea?
Well, it makes it mud and sloppy and wet.
True, and does it weather or erode those sediments?
Oh yeah, it does.
Yeah, so now we've got a really big crack forming. I'm going to take the magma off, okay, and I'm going to pull this back out. So here's what we're going to do. Now that we've got our magma injected into our rock, and we know that because we can see it's literally bowed the surface of the earth up and cracked it. And in the real world, all that water would be flooding down into these things, starting to erode these rocks. And you know what happens is they start to get round. They turn into these round boulders. Okay, so this is the beginning of how Mount Scott formed. In a few minutes, we're going to let this harden, and we're going to come back. And we're going to erode the top off this thing and see what we find. Sound cool? So we filled up our 3-inch baking tin with sand, injected our magma into the bottom, and we've let it cool and crystallize. Okay, and the force of its expansion has actually lifted up the sand above. So we've got a great little model, simulation of what happens when a magma chamber forces its way up into rock. So we want to remove this softer rock now and see what our magma chamber looks like. And see, what shape do you think it is? Do you think it'll be round? Do you think it'll be flat? What shape do you think it'll be?
I think it will be a pentagon.
A pentagon, a shape, a geometric shape. Okay, so you don't think this will just be a round blob? No? I guess not, because he thinks this is going to be a pentagon. So here's the best way to do this, okay? We want to erode this off with water, so we're going to cut the side of the pan very carefully, and we're going to fold back the sides, and that'll allow that water and sediment to move away, okay? Now all we need to do is pour. So now we've got our water jugs. We're going to pour right in the middle, okay, gently, and we're going to wash away all of this sediment. You starting to see anything yet?
I'm starting to see that thing from before.
Yeah, there it is.
That foam.
All right, I'm out of water. You got a little bit more. Go ahead and pour it right on that white thing right there. Give it the business. There you go. You can pour around the edges. So what we're starting to see is that hard, cooled magma is now exposed, right? And so millions of years of exposure of the rocks at the surface caused them to erode away. And this hard rock left below kind of sticks up. But is it round? Let's stop and take a look at it really quick. Okay? That's probably enough water. We can see the edge. What does it look like? What's the shape of it?
It looks like a...
It's a weird shape, isn't it? It's not round. When you think of a magma chamber, it's like this big ball, but the reality is that when igneous rocks cool underground, they force their way into every nook and cranny that they can find, even fractures in the rock above. So this is kind of sticking up, isn't it? So scientists would call this a dike. And a dike is a vertical bit of magma that cools within a fracture. Remember we saw those fractures? Okay, so we would call that a dike. Now at the bottom, pour some water back here. There's a flat part to this as well, okay? And so I'm going to try and pick up the magma chamber now. And you can do this, you just have to get your hands a little dirty, okay? But I'm going to peel the whole magma chamber off the bottom. Now pour some water on it. Oh, look at that. Isn't that cool?
Yes.
So we've got a big flat area, and we would call that a sill. And then this vertical part we would call a dike. And so those are names of igneous rocks. So that is literally how magma might look forced up into these sedimentary rocks if we eroded them all away. Isn't that cool?